Deep space communication systems have achieved a significant milestone by successfully transmitting a laser signal over a distance equivalent to the farthest separation between Earth and Mars. The Psyche mission is currently en route to the metal-rich asteroid of the same name. First discovered in 1852 by Italian astronomer Annibale de Gasparis. 16 Psyche is a metal-rich asteroid located in the asteroid belt at a maximum distance of 600 million kilometers from Earth, with a maximum width of about 279 kilometers. The potato-shaped 16 Psyche is one of the largest known asteroids in the solar system. Scientists are interested in 16 Psyche because it shows signs of being a failed planet, composed of an exposed iron core and outer metal layers. This asteroid may have once been the core of a planet as large as Mars. But violent collisions with other large objects during the solar system's formation prevented it from doing so. Other planetesimals, or small bodies that form the cores of planets, are thought to contain a lot of iron oxide, but these are not found in the core of 16 Psyche. This leads astronomers to believe that this mysterious asteroid may suggest a different type of planet formation mechanism than the one that created Earth. Throughout the journey, the Psyche spacecraft will continue to test future communication systems. A laser beam was transmitted from Earth to the Psyche spacecraft on July 29th, when the spacecraft was 460 million kilometers from the planet. This is not the first time a laser signal has been transmitted between Psyche and Earth. In the past, the spacecraft has transmitted or received data, images, and even color video, but this is the farthest transmission. It is also the farthest distance between Earth and Mars. This milestone is very important. Laser communication requires high precision. And before launching Psyche, we didn't know how much the performance would degrade at the farthest distance, said Meera Srinivasan, project operations lead at NASA's Jet Propulsion Laboratory, JPL, in Southern California. Now that the technology we use to track and navigate has been validated, it confirms that optical communication can become a reliable method for exploring the solar system. The entire deep space optical communication system is experimental, examining what can be done with current technology and guiding future developments. The research team conducted experiments at several different distances to determine the amount of data that could be transmitted. At a distance of 53 million kilometers, equivalent to the closest distance between Mars and Earth, the maximum data rate was 267 megabits per second, comparable to broadband download speeds. On June 24th, when Psyche was 390 million kilometers from Earth, the typical data transmission rate was 6.25 megabits per second, with a maximum of 8.3 megabits per second. The speed decreased significantly compared to the previous test, but was still 100 times faster than radio communication. Researchers were able to download nearly 11 terabytes of data in this first test phase. A key goal for the system is to demonstrate that the decrease in data transmission rate corresponds to the inverse square of the distance, said Abhi Biswas, a project engineer at JPL. The next step of the mission is to reboot. The spacecraft is currently powering down systems and will turn them back on November 4th to demonstrate that it can operate for at least a year. Psyche will continue to fly around the inner solar system for several more years. In 2029, the spacecraft will reach the asteroid 16 Psyche and begin orbiting it until at least the end of 2031. Thanks for watching.